So now that we have seen what glaciers are, where we can find them, and what we need to create them, we're gonna look at how they can appear on this planet. They come in different shape and sizes, or ranked from smallest to biggest. We have the hanging glaciers, cirque glaciers, valley, piedmont, tidewater, ice fields, ice shelves, ice streams, ice caps, and ice sheets. And we'll detail all of those shapes in the following slides. This list is general in the sense that sometimes you can have, for example, a valley glacier that's bigger than a piedmont, or vice versa, but it gives you a sense of what we are talking about. If I'm talking about a hanging glacier or a tidewater glacier, you should know that the tidewater glacier is much bigger than the hanging glacier. So we'll start with that. A hanging glacier is just a small glacier that's clinging on to the side of a steep slope in the mountain. Usually, when they start growing, they can transition to another glacier shape that we'll see a bit later. Glaciers are created in areas where the mountain is making a bowl shape or depression, like what we are seeing here. So the ice is accumulating pretty easily in these configurations, and once the glacier is big enough, it starts flowing out of there. So in those two pictures, actually, those glaciers are completely dying and probably already disappeared from the surface of the Earth. A valley glacier is usually the type of glacier that people think of when they think of a glacier. They're very nice to look at, and they're very how to say, basically the typical glacier shape that you see in the mountains. Like you go around Anchorage, you have the Matanuska. That is an amazing glacier. If you go in France or in Europe, you have also like the Alèche Glacier, the Mer de Glace. Close to Fairbanks, you have the Kastner Glacier. So those glaciers are basically either they probably start as a cirque or hanging glacier, but they are growing, and when they are big enough, they start flowing down the mountain. And what you have is that they either follow paths of least resistance, meaning existing valleys or places where it's easier to flow. And valley glaciers are pretty nice because are easier to study in the sense that their flow is restricted to the valley in which they are. They completely carve those valleys as they are moving, and most of the valleys you see in the mountains are either carved by glaciers or rivers. It's very easy to know if a valley was carved by a glacier because it has a typical U shape. I'll talk a bit about that a bit later in the lecture or in another lecture. But basically, yeah, you can bet that if it's U-shaped, there was a glacier there somehow. If it's V-shaped, if the valley in which you're standing is V-shaped, it probably means that it was carved out by a stream like the one we are seeing here. Here is a picture of the Kastner Glacier ice cave. It's close to Anchorage in Alaskan time. It's only like 3 hours of driving away. I wouldn't advise to go and visit that cave this year anymore because it already collapsed partially last year, and now there's a beautiful arch standing out. But the thing is, this arch is really thin on the top, and we're already reaching above freezing temperature in Alaska, and that arch is definitely gonna collapse this summer. So just wait until, I don't know, next November if you want to go inside the Kastner Glacier Cave. It's a very amazing place. You can actually walk pretty far into the glacier. Last time I was there was what, a month and a half ago, and we could walk like half a mile into the glacier until we reached a mini river, and we didn't really want to cross that stream. That is a Piedmont glacier. And Piedmont glaciers are pretty different from valley glaciers in the sense that when you have that ice that's sitting somewhere and spilling out of its natural boundaries, you can see that Piedmont glaciers are basically flowing in an unrestricted shape. How can I say that better? a valley glacier is constrained by the fact that it's in a valley. It doesn't have many places to go but downhill and follow the valley shape. Piedmont glaciers don't follow any shape. It's ice that spills into, I don't know, some plains or something like that. It has some room, basically. And if you were to pour honey here, for example, and have it flow downhill, it will probably make that kind of similar shape. So they look like big pancakes. They can be pretty big glacier shapes. And yeah, the key word there is unrestricted flow. And that's actually the kind of glacier I'm focusing on. I specifically study the Sit-Line glacier, previously temporarily known as Malaspina. Sit-Line is its original Tlingit name. Sit means big and Line means glacier. And that one is located in Southeast Alaska, close to the little town of Yakutat. It's an amazingly beautiful glacier. It's very difficult to study because of its shape. And it's very big as well. Just that lobe here, hopefully you can see my mouse, my pointer. Just that part here is 2,000 square kilometers. I have no idea how it is in miles, but basically it's half of the size of Rhode Island. So the last type of glaciers for this lecture, for this video, sorry, are tidewater glaciers. So we have a lot of them in Alaska, especially in the southeast on the coast. They are pretty spectacular because you can float to them. Some people use kayaks to go close to them. Just as a general advice, try to stay clear from tidewater glaciers because they have this process that we call calving, and that's when the ice breaks off from the front of the glacier and falls into the ocean. So it can break up from the top of the glacier, from the emerging part of the ice. But whenever you see that ice front, try to think that a lot of ice is actually also below sea level. So below here, you also have a lot of ice, and sometimes the ice breaks off from down here. So it happens that people are surprised because they don't see anything falling from here, but actually you have some piece of ice that's breaking off from below the water and suddenly rises to the surface. And that can do a lot of damage. Yeah, because ice floats generally on water. The difference with tidewater glaciers, though, and very interesting fact is they don't necessarily float themselves. Like all that mass of ice that you see is grounded on the seafloor. So it's probably like maybe 100 meters thick, something like that. So what happens is that as the glacier advances, and we'll see that in more details in one of the last lectures of this part of the course. But whenever the tidewater glacier advances, it builds up a moraine in front of it. It pushes it pushes a lot of rocks, kind of like a bulldozer, and protects itself from deeper waters. So whenever you see a tidewater glacier like that in Alaska, in Alaska in particular, the chances are that this ice is grounded on the floor, and if the ice is thick enough, it might start floating. You might have a floating tongue, just like ice shelves, which we'll cover in the following video. But the thing is that when the ice is not thick enough, what happens is that the glacier is undergoing so much tensile stress. It's like if you're trying to stretch a rubber band or something like that, and basically the ice falls apart. But if the ice is thick enough, even with a lot of tensile stress, the ice kind of stays together and therefore allows for some flotation. But for tidewater glaciers that are usually not thick enough, what you see is just grounded ice that advances through a fjord, and at some point starts calving and breaking off from the main part of the glacier. So yeah, that's the process of calving. Whenever you have ice in the front of a tidewater glacier that falls into the ocean, that breaks away naturally from the main body of ice. That's one way the glacier can lose mass. we talked about melt and stuff like that. Tidewater glaciers, on top of melting, can lose a lot of ice through calving. In some places, this is actually the main mechanism through which tidewater glaciers are losing some mass.